What if I told you that there is a shortage of IV bags in hospitals across the nation? ICU Medical is one of the leading manufacturers of transfusion products in the United States, producing over 800,000 bags per day. This equates to about 1/3 of all IV bags distributed in the United States and Canada. However, because of the current demand-constrained environment, ICU Medical teamed up with Texas A&M Industrial Engineering Capstone Team 5 to assist in attacking one of their most pressing challenges. Currently, there are significant inefficiencies in the packaging area that can be attributed to employee downtime occurring in 2 of ICU Medical's high-volume production lines. The packaging area is the last processing step within our project scope, a scope that begins with filling, overwrapping, then sterilizing. If a shortage is currently taking place across the nation, why are we seeing so much non-productive worker idle time? First, we wanted to identify and mitigate problems directly related to these poor inefficiencies. Additionally, we wanted to establish alternative but sustainable solutions to optimize the production process.
After accurately defining our problem, we began to investigate the root causes for the employee downtime. Using state-of-the-art simulation as a solution verification tool, we were able to accurately predict and highlight problematic areas within the production process. As you are witnessing here, the simulation we designed revealed high-impact bottleneck occurrences. We were able to model and verify 2 production lines and the various products they manufacture. Each product has its own unique set of variables causing fluctuations in the process flow. The ability to predict and diagnose the impact of manufacturing different product combinations was only one of the methods we used to accomplish our goals.
We found it remarkably useful to create a current value stream map to visualize and document the flow of material and information required to produce IV bags, along with highlighting some of the waste in the current system. Using lean methodology, we devised a future value stream map which incorporates the drum buffer rope strategy, a methodology derived directly from Goldrach's theory of constraints. The main premise of this theory is a system can only produce as fast as its slowest process. For example, think of a hiking troop whose goal is to complete a trail as one group. They will only be able to complete the hike as fast as the slowest member.
In our case, the slowest member is sterilization, our bottleneck. We set our drum or pace of the whole system to the bottleneck and implement a buffer before sterilization with a constraint on how large the buffer can grow, known as the rope. Using our simulation study, paired with this future value stream map, we were able to implement the drum buffer rope technique. If applied correctly, this technique prevents overproduction from the fill and overwrap areas while simultaneously controlling inventory and creating a steady flow of material into the pack-out area. In order to carry out the implementation of the drum buffer rope technique, we created a spreadsheet tool to determine the optimal fill rates, to pace the fill areas, and control the inventory buffer. Once we've determined the optimal fill rates, we could model the changes and improve the current production system, all while using our simulation to study the inventory buffer contents.
We accomplished our goal,
Delivering a solution with a justified capability to decrease inefficiencies by 10%.
On behalf of Team 5 and the Texas A&M Industrial and Systems Engineering Department,
We would like to thank ICU Medical and all those who helped us in achieving success.
Gig 'em!